What if I told you that in the vast expanse of the universe, there are phenomena so extraordinary that they defy everything we think we know about reality? Picture this, a single black hole, millions of times more massive than our Sun, warping the fabric of space and time itself. Now imagine that this is just one of countless mysteries waiting to be uncovered. Welcome to the next era of space discovery, where the boundaries of human knowledge are being pushed further than ever before. In this video, we're diving into 25 groundbreaking phenomena that are reshaping our understanding of the cosmos, from interstellar travel breakthroughs to the search for extraterrestrial life. By the end of this journey, you'll not only glimpse the future of space exploration, but also uncover how these discoveries could transform life as we know it. So, are you ready to embark on this cosmic adventure? Let's begin. Now, let's set our sights on the first phenomenon that's propelling us into the future of space exploration: interstellar travel breakthroughs. Imagine a world where traveling to distant star systems isn't just a dream but a tangible reality. This is no longer the stuff of science fiction. Thanks to groundbreaking advancements in propulsion systems, we're closer than ever to making interstellar journeys possible. One of the most exciting developments is the concept of light sails. These are enormous, ultra-thin sails that harness the power of light itself. Yes, light to propel spacecraft forward. By capturing photons from powerful lasers or even the sun, these sails could accelerate spacecraft to speeds previously thought unattainable, potentially reaching nearby star systems within decades instead of millennia. But that's not all. Another game-changing technology on the horizon is antimatter engines. Antimatter, the mysterious counterpart to ordinary matter, releases an incredible amount of energy when it comes into contact with matter. Scientists are exploring how to harness this energy to create propulsion systems that could propel spacecraft at a significant fraction of the speed of light. While the challenges are immense, like producing and storing antimatter safely, the potential rewards are staggering. Imagine reaching Alpha Centauri, our nearest star system, in just a few years instead of tens of thousands. These advancements aren't just about speed, they're about redefining what's possible. With light sails and antimatter engines, we could explore distant star systems, search for habitable planets, and even answer one of humanity's oldest questions: are we alone in the universe? The implications are profound, not just for science but for the future of humanity itself. As we continue to push the boundaries of propulsion technology, the stars are no longer out of reach. They're the next frontier. And speaking of frontiers, let's turn our attention to another cosmic mystery that's capturing the imagination of scientists and dreamers alike: the search for exoplanets. But more on that in just a moment. Now, let's shift our gaze from the vast possibilities of interstellar travel to another thrilling frontier in space exploration: the search for exoplanets. For centuries, humanity has wondered if there are other worlds like ours out there, and today, we're closer than ever to finding out. Thanks to cutting-edge technologies, we're not just discovering planets beyond our solar system, we're identifying ones that could potentially support life. At the forefront of this search is the James Webb Space Telescope, a marvel of modern engineering. Launched in December 2021, this telescope is designed to peer deeper into the cosmos than ever before. Unlike its predecessor, the Hubble Space Telescope, which primarily observed visible light, the James Webb Space Telescope specializes in infrared light. This allows it to see through cosmic dust and detect the faint heat signatures of distant planets, even those orbiting faraway stars. One of the most exciting aspects of the James Webb Space Telescope is its ability to analyze the atmospheres of exoplanets. By studying the light that passes through or reflects off these atmospheres, scientists can identify the presence of key molecules like water vapor, carbon dioxide, and even methane ingredients that could hint at the possibility of life. Already, the telescope has uncovered a treasure trove of Earth-like planets located in what's known as the habitable zone. This is the region around a star where temperatures are just right for liquid water to exist, a crucial ingredient for life as we know it. But the search for exoplanets doesn't stop there. Ground-based observatories and other space telescopes are also playing a vital role. Instruments like the Transiting Exoplanet Survey Satellite, or TESS, are scanning the skies for planets that pass in front of their stars, causing a slight dimming of light that can be detected from Earth. These discoveries are helping scientists build a catalogue of potentially habitable worlds, each one a candidate for further study. The implications of finding an Earth-like exoplanet are profound. It could answer one of humanity's most profound questions. Are we alone in the universe? Beyond that, it could open the door to future missions aimed at exploring these distant worlds, perhaps even paving the way for human colonization. As we continue to uncover more about these distant planets, one thing is clear. The search for exoplanets is not just about finding new worlds, it's about understanding our place in the cosmos. And with each discovery, we're reminded that the universe is far more vast and mysterious than we ever imagined. Next, we'll dive into another cosmic mystery that's reshaping our understanding of the universe: black holes. But more on that in just a moment. Now, let's turn our attention to one of the most enigmatic and awe-inspiring phenomena in the cosmos: black holes. These mysterious objects, once thought to be purely theoretical, have become a focal point of modern astrophysics, thanks to groundbreaking advancements in imaging and research. Black holes are regions of space where gravity is so intense that nothing, not even light, can escape their pull. For decades, they existed only in equations and simulations, but recent breakthroughs have brought them into the realm of observable reality. One of the most monumental achievements in this field came in April 2019, when scientists unveiled the first ever image of a black hole. Captured by the Event Horizon Telescope, a global network of radio telescopes, this historic image revealed the shadow of a supermassive black hole at the center of the galaxy Messier 87, located 55 million light-years away. The image showed a bright ring of light surrounding a dark central region, the event horizon, the point of no return. This achievement was not just a triumph of technology, but also a validation of Einstein's theory of general relativity, which predicted the existence of such objects over a century ago. But why is imaging black holes so important? For starters, it allows scientists to study the extreme environments around these objects, where gravity warps space and time in ways that challenge our understanding of physics. By observing how matter behaves as it spirals into a black hole, researchers can test theories about the nature of gravity, the behavior of light, and the very fabric of space-time. These observations are helping us answer fundamental questions about how the universe works on both the largest and smallest scales. Black holes also play a crucial role in the evolution of galaxies. Supermassive black holes, like the one at the center of Messier 87, are thought to reside at the heart of nearly every galaxy. Their immense gravitational influence can shape the structure of galaxies, regulate star formation, and even eject matter at near-light speeds in the form of powerful jets. Understanding black holes, therefore, is key to understanding the life cycle of galaxies, including our own Milky Way. Recent research has also shed light on the mysterious phenomenon of black hole mergers. When two black holes collide, they create ripples in space-time known as gravitational waves, which were first detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO. These detections have opened a new window into the universe, allowing scientists to listen to the cosmos and study events that would otherwise be invisible. Each merger provides valuable data about the properties of black holes and the nature of gravity itself. As we continue to explore these cosmic giants, one thing is certain: black holes are not just destructive forces, they are also windows into the deepest mysteries of the universe. From testing the limits of our physical theories to uncovering the secrets of galaxy formation, black hole research is reshaping our understanding of reality itself. Next, we'll explore another cosmic puzzle that makes up the majority of the universe yet remains invisible to us: dark matter and dark energy, but more on that in just a moment. Now, shifting our gaze to an even more elusive cosmic mystery, we delve into the invisible forces that dominate the universe: dark matter and dark energy. Together, these two phenomena make up roughly 95% of the universe's total content, yet they remain some of the most perplexing puzzles in modern science. Unlike black holes, which we can now observe indirectly, dark matter and dark energy are entirely invisible, detectable only through their gravitational effects on the visible universe. Let's start with dark matter. This mysterious substance doesn't emit, absorb, or reflect light, making it completely invisible to traditional telescopes. So how do we know it exists? The answer lies in its gravitational influence. Observations of galaxies and galaxy clusters reveal that they rotate and move in ways that can't be explained by the visible matter alone. Stars on the outer edges of galaxies, for example, move much faster than they should if only the visible matter were pulling on them. This discrepancy led scientists to propose the existence of dark matter, an invisible form of matter that provides the extra gravitational glue holding galaxies together. But what is dark matter made of? That's the million-dollar question. While we don't yet know its exact composition, leading theories suggest it could be made up of exotic particles that don't interact with light or ordinary matter. Experiments like those conducted in underground labs or using particle colliders are actively searching for these hypothetical particles, but so far, dark matter has managed to evade detection. Despite this, its presence is undeniable, shaping the large-scale structure of the universe and influencing how galaxies form and evolve. Now, let's turn to dark energy, an even more baffling force. While dark matter pulls things together through gravity, dark energy does the opposite. It pushes the universe apart. In the late 1990s, astronomers made a startling discovery. The expansion of the universe is accelerating, not slowing down as previously thought. This acceleration is driven by dark energy, a mysterious force that permeates all of space. Unlike gravity, which weakens with distance, dark energy's influence grows as the universe expands, making it the dominant force on cosmic scales. The implications of dark energy are profound. It not only explains why the universe is expanding faster and faster, but also raises questions about the ultimate fate of the cosmos. Will dark energy continue to drive the universe apart indefinitely, leading to a cold, empty expanse? Or could its behavior change over time, potentially altering the course of cosmic history? These are questions that cosmologists are actively working to answer, using tools like the James Webb Space Telescope and large-scale surveys of the universe's structure. Together, dark matter and dark energy form the backbone of modern cosmology, shaping our understanding of the universe's past, present, and future. While they remain invisible and largely mysterious, their effects are everywhere, from the rotation of galaxies to the accelerating expansion of space itself. Unlocking their secrets could revolutionize our understanding of the cosmos, revealing not just what the universe is made of, but how it came to be and where it's headed. As we continue to explore these invisible forces, one thing is clear: the universe is far stranger and more complex than we ever imagined. And with that, we'll move on to another frontier of space exploration, one that could change the way we think about resources and sustainability: space mining and resource utilization. But more on that next. Now, let's venture into a realm where science fiction meets reality: the exciting frontier of space mining and resource utilization. Imagine a future where we no longer rely solely on Earth's dwindling resources, but instead tap into the vast wealth of materials scattered across asteroids, moons, and other celestial bodies. This isn't just a dream, it's a rapidly emerging field that could revolutionize space exploration and even life on Earth. Asteroids, often referred to as the gold mines of the solar system, are packed with precious metals like platinum, gold, and rare earth elements. These materials are not only valuable for their monetary worth but also essential for advanced technologies, from electronics to renewable energy systems. For example, a single asteroid could contain enough platinum to meet global demand for decades. But the real game changer lies in the potential to mine water ice, which can be converted into hydrogen and oxygen, key components for rocket fuel. This means we could one day refuel spacecraft in space, drastically reducing the cost and complexity of deep space missions. The Moon, too, holds immense potential. Its surface is rich in helium-3, a rare isotope that could power future fusion reactors, providing a clean and virtually limitless energy source. Additionally, lunar regolith, the layer of loose soil and rock, contains materials like silicon and aluminum, which could be used to construct habitats, tools, and even spacecraft right on the Moon. This concept, known as in situ resource utilization, could enable sustainable lunar bases and serve as a stepping stone for missions to Mars and beyond. But how do we mine in space? The challenges are immense. Unlike Earth, asteroids and moons lack gravity, making traditional mining techniques impractical. Instead, robotic systems and autonomous machines will likely play a crucial role. Companies and space agencies are already developing technologies like asteroid-grabbing spacecraft, lunar rovers equipped with drills, and 3D printers capable of using raw space materials to build structures. These innovations are paving the way for a new era of resource extraction beyond our planet. The implications of space mining are profound. By accessing extraterrestrial resources, we could reduce the environmental impact of mining on Earth, preserve our planet's finite reserves, and unlock new opportunities for economic growth. Moreover, the ability to produce fuel and materials in space would make long-term exploration and colonization feasible, turning humanity into a truly spacefaring species. As we look to the stars, space mining represents not just a technological leap but a paradigm shift in how we think about resources and sustainability. It's a bold vision that could reshape our future, both on Earth and beyond. And with that, we'll turn our attention to another groundbreaking development, the rise of space habitats and colonization. But more on that next. Now, let's shift our gaze to the next frontier in humanity's cosmic journey, the development of space habitats and colonization. Picture this: floating cities in orbit, lunar bases bustling with activity, and Martian settlements thriving under a red sky. These aren't just scenes from science fiction. They're the ambitious goals of scientists, engineers, and visionaries working to make life beyond Earth a reality. The idea of living in space has long captured our imagination, but turning it into a practical endeavor requires overcoming immense challenges. One of the most critical aspects is creating self-sustaining habitats, environments where humans can live, work, and thrive without constant resupply from Earth. These habitats must provide everything we need to survive: breathable air, clean water, nutritious food, and protection from the harsh conditions of space, such as radiation and extreme temperatures. On the Moon, for example, researchers are exploring the concept of building habitats using lunar regolith, the layer of dust and rock covering the surface. By processing this material, we could create bricks, glass, and even metals to construct shelters and infrastructure. Some designs propose using 3D printing technology to build entire lunar bases, layer by layer, using materials found right on the Moon. This approach, known as in situ resource utilization, could drastically reduce the cost and complexity of establishing a permanent presence there. Mars presents an even greater challenge, but also an incredible opportunity. The red planet's thin atmosphere and freezing temperatures make it a hostile environment. but its similarities to Earth, such as a day-night cycle and the presence of water ice, make it a prime candidate for colonization. Scientists are developing innovative solutions like inflatable habitats that can be transported compactly and then expanded on site. These habitats will be equipped with advanced life support systems capable of recycling air and water, and even growing food using hydroponics or aeroponics. Beyond the Moon and Mars, the concept of orbital space habitats is gaining traction. Imagine massive structures like the O'Neill Cylinder, a rotating space station designed to simulate gravity through centrifugal force. These habitats could house thousands of people, complete with farms, parks, and even artificial weather systems. While still in the realm of theory, such designs represent the ultimate vision of a self-sustaining human presence in space. Of course, the challenges are immense. Radiation shielding, psychological well-being, and the logistics of transporting materials and people across vast distances are just a few of the hurdles we must overcome. But the potential rewards are equally staggering. Establishing colonies beyond Earth could serve as a safeguard for humanity, ensuring our survival in the face of global catastrophes. It could also open up new opportunities for scientific discovery, economic growth, and cultural evolution. As we push the boundaries of what's possible, space habitats and colonization represent a bold step toward becoming a multi-planetary species. It's a vision that requires innovation, collaboration, and an unwavering spirit of exploration. And with that, we'll turn our attention to another transformative force shaping the future of space exploration, the role of artificial intelligence. But more on that next. Now, let's take a closer look at how artificial intelligence is revolutionizing the way we explore the cosmos. Imagine a rover on Mars, navigating rocky terrain and making decisions in real time without waiting for instructions from Earth. Or picture a space telescope sifting through millions of data points to identify a distant exoplanet in a matter of seconds. These aren't just futuristic ideas, they're happening right now, thanks to the incredible power of artificial intelligence. One of the most exciting applications of artificial intelligence in space exploration is its role in autonomous systems. Take, for example, the rovers we send to other planets. In the past, these machines relied heavily on commands sent from mission control, which could take minutes or even hours to reach them due to the vast distances involved. But with artificial intelligence, rovers like NASA Perseverance can now analyze their surroundings, avoid obstacles, and even choose the most scientifically interesting rocks to study, all on their own. This level of autonomy not only speeds up exploration, but also allows us to gather more data than ever before. Artificial intelligence is also transforming how we process the enormous amounts of information collected by space missions. Telescopes like the James Webb Space Telescope generate terabytes of data every day, far more than human scientists could ever analyze manually. By using artificial intelligence algorithms, researchers can quickly identify patterns, detect anomalies, and uncover hidden insights in this data. For instance, artificial intelligence has been instrumental in discovering new exoplanets by analyzing tiny dips in starlight caused by planets passing in front of their host stars. Without artificial intelligence, many of these discoveries might have gone unnoticed. Another groundbreaking application is in mission planning and decision-making. Space missions are incredibly complex with countless variables to consider. Artificial intelligence can help optimize trajectories, predict potential risks, and even suggest the best times to launch spacecraft. This not only improves efficiency but also reduces the chances of costly errors. For example, artificial intelligence has been used to plan the most efficient routes for satellites, ensuring they use the least amount of fuel while maximizing their scientific output. But perhaps one of the most intriguing possibilities is the use of artificial intelligence in the search for extraterrestrial life. By analyzing data from distant planets, artificial intelligence can help identify potential biosignatures, chemical or environmental clues that might indicate the presence of life. This could dramatically accelerate our ability to answer one of humanity's most profound questions. Are we alone in the universe? Of course, the integration of artificial intelligence into space exploration isn't without its challenges. Ensuring the reliability of artificial intelligence systems in the harsh conditions of space, addressing ethical concerns about autonomous decision-making, and managing the vast amounts of data generated are all areas that require careful consideration. But the potential benefits are immense, and as artificial intelligence continues to evolve, so too will our ability to explore the cosmos in ways we once thought impossible. As we continue to push the boundaries of what artificial intelligence can achieve, it's clear that this technology is not just a tool, it's a game changer for space exploration. And with that, let's turn our attention to another fascinating phenomenon that's reshaping our understanding of the universe, the detection of gravitational waves. But more on that next. Now, shifting our gaze to another groundbreaking discovery, let's dive into the fascinating world of gravitational wave astronomy. Imagine the universe as a vast, silent ocean, and gravitational waves as the ripples that travel across its surface. These ripples are not made of water, but are distortions in the very fabric of space-time itself, caused by some of the most violent and energetic events in the cosmos. Detecting these waves has opened up an entirely new way for us to observe and understand the universe. Gravitational waves were first predicted by Albert Einstein over a century ago as part of his theory of general relativity. However, it wasn't until 2015 that scientists made the first direct detection using the Laser Interferometer Gravitational Wave Observatory, or LIGO. This monumental achievement confirmed Einstein's prediction and marked the beginning of a new era in astronomy. Unlike traditional telescopes that rely on light, gravitational wave detectors allow us to listen to the universe, picking up signals from events that are invisible to other instruments. One of the most dramatic sources of gravitational waves is the collision of massive objects like black holes or neutron stars. When two black holes spiral toward each other and merge, they send out ripples that travel across the universe at the speed of light. These ripples carry information about the objects that created them, such as their masses, spins, and distances. In 2017, LIGO and its European counterpart, Virgo, detected gravitational waves from the collision of two neutron stars. This event was not only heard through gravitational waves, but also observed by telescopes across the electromagnetic spectrum, from gamma rays to radio waves. This multi-messenger astronomy provided a wealth of data, helping scientists understand how heavy elements like gold and platinum are formed in such cosmic collisions. But gravitational wave astronomy isn't just about detecting collisions. It also offers a unique way to study the properties of black holes and neutron stars, objects that are otherwise difficult to observe directly. For example, gravitational waves can reveal the internal structure of neutron stars, which are so dense that a single teaspoon of their material would weigh billions of tons. By studying these waves, scientists hope to unlock the secrets of matter under extreme conditions, shedding light on the fundamental laws of physics. The future of gravitational wave astronomy is incredibly promising. New detectors like the planned Laser Interferometer Space Antenna, or LISA, will be able to observe lower frequency gravitational waves, allowing us to detect even more exotic events, such as the mergers of supermassive black holes at the centers of galaxies. These observations could help us understand how galaxies form and evolve over time. As we continue to refine our ability to detect and interpret gravitational waves, we're not just observing the universe, we're listening to its symphony. Each ripple tells a story, revealing the hidden dynamics of the cosmos in ways we've never imagined. And with that, let's turn our attention to another exciting development in the next era of space discovery: the rise of private space companies and their role in accelerating innovation. But more on that soon. Now, let's pivot to a development that's reshaping the landscape of space exploration: the rise of private space companies. Over the past 2 decades, organizations like SpaceX, Blue Origin, and others have emerged as key players in the quest to explore and utilize space. These companies are not just supplementing government-led efforts, they're driving innovation at an unprecedented pace, making space more accessible and opening up possibilities that were once the stuff of science fiction. SpaceX, founded by Elon Musk in 2002, has become a household name thanks to its groundbreaking achievements. From launching the first privately funded spacecraft to reach orbit to developing the reusable Falcon 9 rocket, SpaceX has dramatically reduced the cost of space travel. Their Starship project, currently in development, aims to take humans to Mars, potentially paving the way for interplanetary colonization. But SpaceX isn't just focused on distant goals. It's also revolutionizing satellite deployment with its Starlink constellation, which aims to provide global internet coverage from space. Blue Origin, founded by Jeff Bezos, is another major player in the private space industry. While it may not have the same high-profile launches as SpaceX, Blue Origin is making significant strides with its new Shepard suborbital vehicle, designed to take tourists to the edge of space. The company is also developing the New Glenn rocket, a heavy-lift vehicle intended to compete with SpaceX's Falcon Heavy. Blue Origin's long-term vision includes building infrastructure in space, such as lunar landers and habitats, to support future missions to the Moon and beyond. But it's not just these two giants making waves. Companies like Rocket Lab, Virgin Galactic, and Relativity Space are also pushing boundaries. Rocket Lab specializes in small satellite launches, offering affordable and frequent access to space for businesses and researchers. Virgin Galactic, led by Richard Branson, is pioneering space tourism, offering civilians the chance to experience weightlessness and see Earth from the edge of space. Relativity Space, on the other hand, is leveraging three-dimensional printing technology to manufacture rockets faster and more efficiently than ever before. The impact of these private companies extends beyond technological advancements. They're fostering a new era of competition and collaboration, driving down costs and accelerating innovation. By taking on projects that were once the sole domain of government agencies, they're freeing up resources for even more ambitious missions. For example, NASA Artemis program, which aims to return humans to the Moon, is partnering with private companies to develop lunar landers and other critical technologies. This shift toward privatization is also democratizing space. With more players in the field, opportunities for research, exploration, and even tourism are expanding. Universities, startups, and smaller nations can now participate in space missions that were previously out of reach. And as private companies continue to innovate, the dream of a multi-planetary future feels closer than ever. As we look ahead, the role of private space companies will only grow. Their contributions are not just transforming how we explore space, they're redefining why we explore it. And with that, let's turn our attention to another exciting frontier: the concept of space-based solar power and its potential to revolutionize energy on Earth. But more on that soon. Now, let's shift our gaze to a concept that sounds like it's straight out of a sci-fi novel but is steadily becoming a reality: space-based solar power. Imagine harnessing the sun's energy not just here on Earth, but directly from space, where sunlight is uninterrupted by clouds, nights, or atmospheric interference. This idea, once a distant dream, is now being seriously explored as a potential game-changer for sustainable energy on our planet. The concept is simple yet revolutionary. Solar panels placed in orbit around Earth would collect sunlight 24 hours a day, 7 days a week, converting it into electricity. This energy would then be transmitted back to Earth using wireless technologies such as microwaves or lasers, and received by ground-based stations. From there, it could be fed into the power grid, providing a constant and reliable source of clean energy. Unlike traditional solar farms on Earth, space-based solar power systems wouldn't be affected by weather conditions or the day-night cycle, making them incredibly efficient. One of the biggest advantages of this approach is its scalability. Space offers virtually unlimited real estate for solar arrays, and the energy potential is staggering. A single large-scale solar power station in space could generate enough electricity to power entire cities, reducing our reliance on fossil fuels and significantly cutting greenhouse gas emissions. This could be a major step forward in combating climate change and ensuring a sustainable future for generations to come. But how feasible is this idea? While the technology is still in its early stages, significant progress has already been made. Organizations like the Japan Aerospace Exploration Agency and the European Space Agency have been actively researching space-based solar power, conducting experiments to test the viability of wireless energy transmission. Private companies are also joining the effort, with startups like Solaran and Space Solar exploring innovative designs for orbital power stations. Of course, there are challenges to overcome. Building and launching massive solar arrays into space is no small feat, and the cost of such projects is currently prohibitive. However, advancements in reusable rocket technology, like those pioneered by SpaceX, are driving down launch costs, making the idea more economically viable. Additionally, the development of lightweight, flexible solar panels and more efficient energy transmission systems is bringing us closer to turning this vision into reality. The environmental benefits of space-based solar power are undeniable, but the implications go beyond just clean energy. This technology could also provide a reliable power source for remote or disaster-stricken areas where traditional infrastructure is lacking or damaged. It could even support future space missions, supplying energy to lunar bases or Mars colonies, furthering humanity's reach into the cosmos. As we continue to explore this exciting frontier, the potential of space-based solar power becomes increasingly clear. It's not just about solving Earth's energy crisis, it's about unlocking a new era of innovation and sustainability. And with that, let's turn our attention to another groundbreaking development, the potential of quantum communication in space and how it could revolutionize the way we transmit information across the cosmos. But more on that soon. Now, let's venture into a realm that feels like it's pulled straight from the future: quantum communication in space. This isn't just about sending messages faster or farther. It's about redefining the very nature of how we transmit information across the cosmos. At the heart of this revolutionary concept lies quantum entanglement, a phenomenon so strange and fascinating that even Albert Einstein famously called it spooky action at a distance. Quantum entanglement occurs when two particles become linked in such a way that the state of one instantly influences the state of the other, no matter how far apart they are. This means that if you measure one particle here on Earth, its entangled partner, even if it's light years away, will immediately reflect that measurement. This bizarre connection could be the key to creating ultra-secure communication networks that are virtually impossible to hack or intercept. Imagine a future where astronauts on Mars or deep space probes can send messages back to Earth with absolute security. Traditional communication methods rely on radio waves, which can be intercepted or disrupted. But with quantum communication, any attempt to eavesdrop on the signal would instantly alter the entangled particles, alerting both sender and receiver to the intrusion. This level of security could be a game changer for sensitive missions, from military operations to scientific research. The potential applications of quantum communication in space are vast. For instance, it could enable real-time, secure data transfer between Earth and distant colonies, ensuring that critical information remains protected. It could also revolutionize global communication networks, providing a backbone for unhackable internet systems that span the planet. And let's not forget its role in advancing our understanding of the universe itself. Quantum communication could allow us to test fundamental physics theories in ways that were previously unimaginable. But how close are we to making this a reality? While the concept is still in its experimental stages, significant strides have already been made. Researchers have successfully demonstrated quantum entanglement over distances of hundreds of kilometers, and experiments aboard satellites like China's Missions have shown that quantum communication is possible even in the harsh environment of space. These breakthroughs are paving the way for more ambitious projects, such as creating a global quantum communication network or even establishing quantum links between Earth and the Moon. Of course, there are challenges to overcome. Maintaining the delicate state of entangled particles over vast distances is no easy task, and the technology required to build and deploy quantum communication systems is still in its infancy. But with the rapid pace of advancements in quantum physics and space technology, these hurdles are not insurmountable. In fact, many experts believe that quantum communication could become a cornerstone of future space exploration, enabling secure and instantaneous communication across the solar system and beyond. As we look to the stars, the possibilities of quantum communication remind us that the universe is full of mysteries waiting to be unlocked. This isn't just about improving how we talk to each other. It's about pushing the boundaries of what's possible and opening up new frontiers in science and technology. And with that, let's turn our attention to another fascinating topic: the search for extraterrestrial life and the technologies that could help us detect signs of life beyond our planet. But more on that soon. Now, let's shift our gaze to one of the most profound questions humanity has ever asked. Are we alone in the universe? The search for extraterrestrial life has captivated scientists, dreamers, and explorers for centuries, and today we're closer than ever to finding answers. This isn't just about spotting little green men, it's about uncovering the tiniest hints of life, from microscopic organisms to advanced civilizations, and understanding what that means for our place in the cosmos. One of the most exciting developments in this field is the advancement of astrobiology, the study of life beyond Earth. Scientists are now equipped with cutting-edge tools and missions designed to detect even the faintest traces of life. Take, for example, the Mars rovers like Perseverance, which is actively searching for signs of ancient microbial life in the red planet's rocks and soil. By analyzing samples for organic molecules and other biosignatures, these rovers are helping us piece together the puzzle of whether life once existed or still exists on Mars. But Mars isn't the only target in our solar system. Moons like Europa orbiting Jupiter and Enceladus circling Saturn have become hotspots for astrobiological research. Both are believed to harbor vast oceans beneath their icy surfaces, and where there's liquid water, there's potential for life. Missions like the upcoming Europa Clipper aim to study these moons up close, searching for plumes of water vapor and other clues that could hint at habitable conditions below the ice. Beyond our solar system, the search for extraterrestrial life has taken a giant leap forward with the discovery of exoplanets worlds orbiting other stars. Telescopes like the James Webb Space Telescope are now capable of analyzing the atmospheres of these distant planets, looking for gases like oxygen, methane, or carbon dioxide that could indicate biological activity. Some of these exoplanets lie within the habitable zone, the region around a star where temperatures might allow liquid water to exist, a key ingredient for life as we know it. And then there's the search for intelligent life. Projects like SETI, the search for extraterrestrial intelligence, are scanning the skies for signals that could indicate the presence of advanced civilizations. Using massive radio telescopes, scientists listen for patterns or anomalies in cosmic noise that might suggest a deliberate attempt at communication. While we haven't found definitive proof yet, the sheer scale of the universe means the possibilities are endless. Of course, the search for extraterrestrial life isn't without its challenges. Detecting life, especially microbial life, requires incredibly sensitive instruments and a deep understanding of what to look for. And when it comes to intelligent life, the vast distances between stars make communication, let alone travel, a monumental task. But these challenges haven't deterred us. In fact, they've only fueled our determination to explore further and dig deeper. As we continue to push the boundaries of science and technology, the search for extraterrestrial life reminds us of something profound. The universe is vast, mysterious, and full of potential. Whether we find microbes on Mars, fish in Europa's oceans, or signals from a distant star, each discovery brings us closer to answering that age-old question, are we alone? And with that, let's turn our attention to another fascinating phenomenon, space weather and its impact on our planet and beyond, but more on that soon. Now, let's turn our attention to something that might seem invisible but has a profound impact on our planet and beyond, space weather. Unlike the weather we experience on Earth, space weather involves the dynamic conditions in our solar system, driven primarily by the sun. From solar flares to cosmic rays, these phenomena can influence everything from satellite operations to power grids on Earth, making them a critical area of study for scientists and engineers alike. At the heart of space weather is the sun, a massive ball of plasma that constantly releases energy in the form of light, heat, and charged particles. One of the most dramatic events the sun produces is a solar flare, a sudden burst of energy that can send intense radiation and particles hurtling through space. These flares are often accompanied by coronal mass ejections, or CME, which are massive clouds of solar material ejected into space at incredible speeds. When these particles reach Earth, they can interact with our planet's magnetic field, creating stunning auroras but also posing risks to technology. For example, strong solar storms have the potential to disrupt satellite communications, GPS systems, and even power grids. In one notable event in 1989, a powerful geomagnetic storm caused by a CME knocked out power across Quebec, Canada, leaving millions without electricity for hours. This incident highlighted just how vulnerable our modern infrastructure can be to the whims of space weather. Today, scientists are working to better predict these events, using satellites like the Solar and Heliospheric Observatory, or SOHO, to monitor the sun's activity and provide early warnings. But space weather doesn't just affect Earth, it also poses challenges for astronauts and spacecraft. Cosmic rays, high-energy particles originating from outside our solar system, can penetrate spacecraft and pose health risks to astronauts, increasing their exposure to radiation. This is especially concerning for long-duration missions, such as those to Mars, where astronauts would be far from the protective shield of Earth's magnetic field. To address this, researchers are developing new materials and shielding technologies to protect both humans and equipment from these harmful particles. Interestingly, space weather also plays a role in shaping the atmospheres of other planets. For instance, Mars, which lacks a global magnetic field, is more vulnerable to solar radiation, which has stripped away much of its atmosphere over billions of years. Studying these effects helps scientists understand not only the history of Mars, but also the potential habitability of other worlds. As we continue to explore the cosmos, understanding space weather becomes increasingly important. It's a reminder that our planet is part of a larger, interconnected system, and that the sun's activity can have far-reaching consequences. By studying these phenomena, we're not only safeguarding our technology and astronauts, but also gaining deeper insights into the forces that shape our solar system. And with that, let's move on to another captivating topic, the expansion of the universe and what it means for the future of everything we know. Now, shifting our gaze to the grandest scale of all, let's delve into one of the most profound mysteries of the cosmos, the expansion of the universe. For decades, scientists have known that the universe is not static but is instead stretching outward, carrying galaxies farther apart over time. But what's truly mind-boggling is that this expansion isn't slowing down, it's accelerating. This discovery, first made in the late 1990s, has reshaped our understanding of the universe and raised questions about its ultimate fate. The story begins with Edwin Hubble, who in the 1920s observed that distant galaxies were moving away from us, and the farther they were, the faster they seemed to be receding. This led to the idea of an expanding universe, a cornerstone of modern cosmology. But the real twist came when astronomers studying distant supernova found that the expansion rate wasn't just steady, it was speeding up. This unexpected finding pointed to the existence of a mysterious force called dark energy, which makes up about 68% of the universe and acts as a kind of anti-gravity, pushing galaxies apart. So, what does this mean for the future? If dark energy continues to dominate, the universe will keep expanding at an ever-increasing rate. Over billions of years, galaxies will drift so far apart that they'll no longer be visible to one another. Stars will burn out and the universe will grow colder and darker, a scenario often referred to as the Big Freeze, but this isn't the only possibility. Some theories suggest that dark energy's influence could change over time, potentially leading to other outcomes like the Big Rip, where the expansion becomes so extreme that it tears apart galaxies, stars, and even atoms. To better understand these possibilities, scientists are using powerful tools like the Hubble Space Telescope and the upcoming Nancy Grace Roman Space Telescope to measure the expansion rate with unprecedented precision. They're also studying the cosmic microwave background, the faint afterglow of the Big Bang, to uncover clues about dark energy's nature. These observations are helping us piece together the puzzle of how the universe has evolved and where it might be headed. The implications of this accelerating expansion are staggering. It challenges our understanding of physics, forcing us to rethink fundamental concepts like gravity and energy. It also raises philosophical questions about the nature of existence and the ultimate destiny of everything we know. As we continue to explore this phenomenon, we're not just learning about the universe, we're uncovering the story of our own place within it. And with that, let's turn our attention to another fascinating frontier, the theoretical possibilities of space-time manipulation and what it could mean for the future of space travel. Now, let's venture into the realm of the extraordinary space-time manipulation. This concept, often seen in science fiction, is rooted in real scientific theories that could one day revolutionize how we travel through the cosmos. Imagine being able to bend the fabric of space and time itself, creating shortcuts across the universe or traveling faster than the speed of light. While it may sound like the stuff of dreams, these ideas are grounded in the work of brilliant minds like Albert Einstein and his theory of general relativity. One of the most intriguing possibilities is the concept of wormholes. Picture a tunnel connecting two distant points in space-time, allowing a spacecraft to traverse vast cosmic distances in an instant. These hypothetical passages, also known as Einstein-Rosen bridges, are solutions to the equations of general relativity. While no wormholes have been observed, their existence remains a tantalizing possibility. The challenge lies in stabilizing them, as they would require exotic matter with negative energy to keep them open, something we haven't yet discovered. Then there's the idea of warp drives, popularized by science fiction but also explored by physicists. A warp drive would work by contracting space in front of a spacecraft and expanding it behind, effectively creating a bubble of space-time that moves faster than light. This concept, known as the Alcubierre drive, doesn't violate Einstein's theory because the spacecraft itself isn't moving faster than light. It's the space around it that's being manipulated. While the energy requirements are currently beyond our capabilities, ongoing research is exploring ways to make this idea feasible. The implications of space-time manipulation are staggering. It could allow us to explore distant star systems, visit exoplanets, and even establish contact with other civilizations. but it also raises profound questions about the nature of reality. Could we create stable wormholes? What would happen if we altered the fabric of space-time? And how would these technologies impact our understanding of the universe? As we continue to push the boundaries of physics, these theoretical concepts remind us that the universe is far more mysterious and wondrous than we can imagine. While the practical applications may still be far off, the pursuit of space-time manipulation inspires us to dream bigger and reach further. And with that, let's turn our attention to another fascinating frontier: the emerging field of space archaeology and how it's uncovering secrets of ancient civilizations from the vantage point of space. Now, shifting our gaze from the theoretical wonders of space-time manipulation, let's explore a field that bridges the past and the future: space archaeology. This fascinating discipline uses advanced space-based technologies to uncover secrets of ancient civilizations, offering us a unique perspective on human history. By analyzing satellite imagery and other remote sensing tools, researchers are able to detect hidden structures, lost cities, and even entire civilizations that have been buried for centuries. One of the most powerful tools in this field is high-resolution satellite imagery. These images, captured from orbit, can reveal subtle changes in the Earth's surface that are invisible to the naked eye. For example, variations in vegetation growth or soil composition can indicate the presence of ancient walls, roads, or even entire settlements. This technology has led to the rediscovery of long-lost cities, such as the ancient Mayan metropolis of Tikal, hidden beneath dense jungle canopies for centuries. Another groundbreaking application is the use of LiDAR, or light detection and ranging, which can penetrate thick vegetation to create detailed three-dimensional maps of the terrain. This technique has revolutionized our understanding of ancient landscapes, revealing intricate networks of roads, canals, and buildings that were previously unknown. In Cambodia, for instance, LiDAR has uncovered a sprawling urban complex around the famous Angkor Wat temple, shedding new light on the sophistication of the Khmer Empire. Space archaeology isn't just about uncovering physical structures, it also helps us understand how ancient societies interacted with their environment. By studying patterns of land use, water management, and resource distribution, researchers can piece together how civilizations thrived or declined. For example, satellite data has shown how the ancient Egyptians engineered their agricultural systems to harness the Nile's floods, sustaining one of history's most enduring civilizations. The implications of this field are profound. Not only does it deepen our understanding of human history, but it also highlights the resilience and ingenuity of past societies. By learning from their successes and failures, we can gain valuable insights into how to address modern challenges like climate change and resource management. Space archaeology reminds us that the past holds lessons for the future, and that the tools we use to explore the cosmos can also help us uncover the mysteries of our own planet. As we continue to refine these technologies, the possibilities for discovery are endless. From lost cities to forgotten empires, space archaeology is rewriting the story of human civilization, one satellite image at a time. And with that, let's turn our attention to another cutting-edge field: the role of nanotechnology in space exploration, and how tiny machines could revolutionize our journey into the cosmos. Now, as we venture into the realm of the incredibly small, let's explore how nanotechnology is poised to make a giant leap in space exploration. Imagine machines so tiny they're measured in billionths of a meter, yet capable of transforming how we design, repair, and explore spacecraft. This is the promise of nanotechnology, a field that's redefining the boundaries of what's possible in space. At the heart of this revolution are nanomaterials, substances engineered at the atomic or molecular level to possess extraordinary properties. For instance, carbon nanotubes are stronger than steel yet incredibly lightweight, making them ideal for building spacecraft that can withstand the harsh conditions of space while minimizing weight. These materials could lead to the development of more efficient rockets, reducing fuel consumption and enabling longer missions to distant planets and beyond. But nanotechnology isn't just about materials, it's also about tiny machines that can perform tasks once thought impossible. Picture swarms of microscopic robots or nanobots deployed to repair damaged spacecraft or assemble structures in orbit. These nanobots could work autonomously, patching up cracks in a spaceship's hull or constructing solar panels on the surface of the moon. This capability would drastically reduce the need for risky and expensive human spacewalks, making space missions safer and more cost-effective. Another exciting application is in propulsion systems. Researchers are exploring the use of nanosatellites or CubeSats, equipped with miniature thrusters powered by nanotechnology. These tiny satellites could travel in formation, acting as a distributed network to study distant asteroids or even interstellar space. Their small size and low cost make them an attractive option for missions that would be too risky or expensive for larger spacecraft. Nanotechnology also holds the key to improving life support systems for astronauts. Imagine nanosensors embedded in spacesuits that monitor vital signs in real time, alerting crew members to potential health issues before they become critical. Or consider nanofilters that purify water and air with unparalleled efficiency, ensuring a sustainable environment for long-duration missions. These innovations could be game changers for human exploration of Mars and beyond. The potential of nanotechnology extends beyond our solar system. Scientists are investigating the concept of self-replicating nanobots that could travel to distant star systems, using local resources to build infrastructure for future human missions. While this idea is still in its infancy, it represents a bold vision for how nanotechnology could enable interstellar exploration. As we continue to push the boundaries of what's possible, nanotechnology is proving to be a powerful tool in our quest to explore the cosmos. From stronger materials to autonomous repair systems, these tiny innovations are paving the way for a new era of space exploration. And with that, let's turn our attention to another fascinating topic: the ethics of space exploration and the moral questions that arise as we reach further into the unknown. As we marvel at the incredible advancements in space exploration, it's essential to pause and reflect on the ethical questions that come with venturing into the cosmos. The ethics of space exploration is a topic that challenges us to consider not just what we can do, but what we should do as we reach further into the unknown. Let's dive into some of the most pressing moral dilemmas that arise as humanity sets its sights on the stars. One of the most debated issues is space colonization. As we plan to establish human settlements on the Moon, Mars, and beyond, we must ask ourselves, who has the right to claim these celestial bodies? Should space be treated as a shared resource for all of humanity, or will it become a new frontier for exploitation by a select few? The Outer Space Treaty of 1967 declares that space is the province of all mankind. But as private companies and nations race to stake their claims, the lines between exploration and exploitation are becoming increasingly blurred. Resource exploitation is another ethical minefield. Asteroids and moons are rich in rare materials like platinum and helium-3, which could fuel future space missions and even benefit Earth's economy. But mining these resources raises questions about environmental impact and fairness. Could extracting materials from space disrupt delicate cosmic ecosystems we don't yet fully understand? And how do we ensure that the benefits of space mining are distributed equitably, rather than creating a new era of space-based inequality? Then there's the question of extraterrestrial life. If we discover microbial life on Mars or intelligent civilizations in distant star systems, how should we interact with them? Do we have the right to alter their environments, or should we prioritize preserving their existence as it is? The concept of planetary protection becomes crucial here, as we must balance our desire to explore with the responsibility to avoid contaminating other worlds with Earth-based organisms or inadvertently causing harm to alien ecosystems. The ethics of space exploration also extend to the treatment of astronauts and space workers. As missions become longer and more dangerous, how do we ensure the well-being of those who risk their lives to push the boundaries of human knowledge? Issues like mental health, radiation exposure, and the long-term effects of microgravity must be addressed with care and compassion, ensuring that space exploration remains a humane endeavor. Finally, there's the philosophical question of our place in the universe. As we venture further into space, we're forced to confront our own insignificance in the grand cosmic scheme. This raises profound questions about the purpose of exploration itself. Are we seeking to expand our horizons, or are we driven by a deeper need to understand our origins and destiny? These questions remind us that space exploration is not just a scientific endeavor, it's a deeply human one. As we grapple with these ethical challenges, one thing is clear: the decisions we make today will shape the future of space exploration for generations to come. It's up to us to ensure that our journey into the cosmos is guided by principles of fairness, responsibility, and respect, not just for our own species, but for the universe as a whole. And with that, let's turn our attention to another exciting frontier: the growing industry of space tourism and its potential to make the stars accessible to everyone. Now, let's shift our gaze to a phenomenon that's bringing the cosmos closer to everyday life: space tourism. What was once the stuff of science fiction is now becoming a reality, as private companies are paving the way for ordinary people to experience the wonders of space. This emerging industry is not just about luxury, it's about democratizing access to the stars and redefining what it means to explore the universe. Space tourism is already taking its first steps, with companies like SpaceX, Blue Origin, and Virgin Galactic leading the charge. These pioneers are offering suborbital flights that allow passengers to experience weightlessness and see the curvature of Earth from the edge of space. While these trips are currently reserved for the ultra-wealthy, the long-term vision is to make space travel as common as flying on an airplane. Imagine a future where a weekend getaway could include a trip to a space hotel orbiting Earth, offering breathtaking views and a truly out-of-this-world experience. But the potential of space tourism goes beyond just leisure. It could also serve as a stepping stone for broader space exploration. By making space travel more accessible, we could inspire a new generation of scientists, engineers, and dreamers who might one day push the boundaries of what's possible. Think about it: the more people who experience space firsthand, the more likely we are to see increased public support and funding for space missions, both governmental and private. Of course, there are challenges to overcome. Safety is a top priority, as space travel remains inherently risky. Companies will need to ensure that their vehicles are not only reliable but also capable of handling emergencies in the harsh environment of space. Additionally, the environmental impact of frequent launches must be addressed, as rocket emissions could contribute to climate change if not managed responsibly. Balancing innovation with sustainability will be key to the long-term success of space tourism. Another exciting aspect of space tourism is its potential to foster international collaboration. As more countries and companies enter the space tourism market, we could see partnerships that transcend borders, bringing people together in pursuit of a shared cosmic adventure. This could help bridge cultural divides and remind us of our common humanity as we look back at our fragile planet from the vastness of space. Looking ahead, the future of space tourism is full of possibilities. From lunar vacations to orbital resorts, the industry is poised to transform how we think about travel and exploration. And as technology advances and costs decrease, the dream of space travel could become a reality for millions, not just a privileged few. This isn't just about seeing the stars, it's about bringing the stars within reach for everyone. As we continue to explore the next era of space phenomena, the rise of space tourism reminds us that the cosmos isn't just for astronauts and scientists, it's for all of us. And with that, let's turn our attention to another fascinating concept, the multiverse theory and how space exploration might one day provide evidence for parallel universes. Now, let's venture into a concept that stretches the boundaries of our imagination, the multiverse theory. This idea suggests that our universe might not be the only one out there. Instead, it could be just one of countless parallel universes, each with its own unique set of physical laws and realities. While this might sound like something straight out of a science fiction novel, it's a serious topic of discussion among physicists and cosmologists, and space exploration could play a key role in uncovering evidence for its existence. The multiverse theory arises from several areas of modern physics, including quantum mechanics and string theory. For instance, in quantum mechanics, every possible outcome of a situation might exist in its own separate universe. Meanwhile, string theory proposes that our universe is just one brain, floating in a higher dimensional space alongside many others. These ideas, while still theoretical, offer fascinating possibilities for understanding the nature of reality. But how could we ever prove that these parallel universes are real? That's where space exploration comes in. One potential avenue for evidence lies in the study of cosmic microwave background radiation, the faint afterglow of the Big Bang. Scientists have speculated that if our universe collided with another in the distant past, it might have left behind detectable imprints in this radiation. Advanced space telescopes and observatories could one day spot these subtle anomalies, providing the first hints of a multiverse. Similarly, experiments in particle physics, conducted in space where conditions are ideal, might reveal particles or forces that don't fit within our current understanding of the universe, pointing to the existence of other realities. Another intriguing possibility involves black holes. Some theories suggest that black holes could act as gateways to other universes or even create new ones. By studying these mysterious objects more closely, we might uncover clues about how universes are born and whether they're connected in ways we can't yet comprehend. Missions like the Event Horizon Telescope, which captured the first image of a black hole, are already pushing the boundaries of what we know, and future advancements could bring us even closer to answering these profound questions. The implications of the multiverse theory are staggering. If true, it would mean that every decision we make, every path we take, could exist in a parallel universe where things unfolded differently. It challenges our understanding of existence itself and raises questions about the nature of reality, free will, and the limits of human knowledge. While we're still far from proving the multiverse, the pursuit of this idea drives some of the most exciting research in physics and space exploration today. As we continue to push the boundaries of our understanding, the multiverse theory reminds us that the universe or universes are far stranger and more complex than we can imagine. And with that, let's turn our attention to the next frontier, space-based observatories and how they're revolutionizing our ability to peer deeper into the cosmos than ever before. Now, shifting our gaze to the tools that make these cosmic discoveries possible, let's explore the next generation of space-based observatories. These cutting-edge instruments are set to revolutionize our understanding of the universe, allowing us to peer deeper into the cosmos than ever before. Unlike ground-based telescopes, which are limited by Earth's atmosphere, space-based observatories operate in the vacuum of space, free from atmospheric distortion. This gives them an unparalleled ability to capture incredibly sharp and detailed images of distant stars, galaxies, and other celestial phenomena. One of the most anticipated projects is the James Webb Space Telescope, which has already begun to deliver breathtaking images and data. Positioned nearly 1 million miles from Earth, this observatory is designed to observe the universe in infrared light, revealing hidden details about the formation of stars, galaxies, and even the atmospheres of distant exoplanets. But the James Webb is just the beginning. Future observatories like the Nancy Grace Roman Space Telescope will expand our capabilities even further, mapping the universe in unprecedented detail and helping us unravel the mysteries of dark energy and dark matter. Another exciting development is the concept of interferometry, where multiple telescopes work together as a single, massive instrument. Projects like the Laser Interferometer Space Antenna, or LISA, aim to detect gravitational waves from space, offering a new way to observe cosmic events like black hole mergers and neutron star collisions. These observatories will not only deepen our understanding of the universe, but also open up entirely new fields of study, from the behavior of space-time to the origins of the cosmos. The advancements in space-based observatories are also making it possible to study the universe in ways we once thought impossible. For example, the Habitable Worlds Observatory, currently in the planning stages, will focus on finding and analyzing Earth-like planets in habitable zones around other stars. By studying their atmospheres for signs of water, oxygen, and even potential biosignatures, this observatory could bring us closer to answering one of humanity's most profound questions: are we alone in the universe? As these next-generation observatories come online, they will not only expand our knowledge but also inspire new questions and possibilities. They remind us that the universe is vast, mysterious, and full of wonders waiting to be discovered. With that in mind, let's turn our attention to another critical tool in our cosmic toolkit: the role of robotics in space exploration and how they're transforming our ability to explore the unknown. Now, as we venture into the realm of robotics, it's clear that these mechanical marvels are reshaping the way we explore the cosmos. Robots and drones are no longer just tools. They're becoming indispensable partners in our quest to uncover the secrets of the universe. From navigating treacherous terrains to conducting experiments in environments too hostile for humans, robotics is opening doors to regions of space that were once beyond our reach. Take, for example, the Mars rovers like Curiosity and Perseverance. These robotic explorers have been our eyes and hands on the red planet, traversing its rocky surface, analyzing soil samples, and even searching for signs of ancient microbial life. Their ability to operate autonomously in such a harsh environment is a testament to how far robotics has come. But it doesn't stop there. Future missions are set to deploy even more advanced robots, equipped with artificial intelligence to make real-time decisions and adapt to unexpected challenges. Drones are also playing a pivotal role, especially in exploring places where traditional rovers can't go. Imagine a drone flying through the icy plumes of Saturn's moon Enceladus, collecting samples from its subsurface ocean, or navigating the jagged cliffs of a distant asteroid. These agile machines can access areas that would be impossible for humans or larger vehicles to reach, giving us a closer look at some of the most intriguing corners of our solar system. Robotics is also revolutionizing how we maintain and repair spacecraft. Projects like the Robotic Refueling Mission have demonstrated how robots can perform delicate tasks such as refueling satellites in orbit, extending their operational life and reducing space debris. This capability is crucial as we rely more on satellites for communication, navigation, and scientific research. Beyond exploration and maintenance, robots are even being designed to assist in constructing habitats on the Moon and Mars. These construction robots could lay foundations, assemble structures, and prepare sites for human arrival, making the dream of space colonization a tangible reality. By taking on these labor-intensive tasks, they allow human astronauts to focus on more complex and creative aspects of space missions. As robotics technology continues to evolve, its applications in space exploration will only grow more sophisticated. These machines are not just tools, they're extensions of our curiosity and ingenuity, enabling us to push the boundaries of what's possible. With that in mind, let's turn our attention to another groundbreaking development: the future of space communication and how it's transforming our ability to stay connected across the vastness of the cosmos. Now, as we shift our focus to the future of space communication, it's fascinating to see how technology is bridging the vast distances of the cosmos. Communication is the lifeline of any space mission, and as we venture deeper into the universe, the need for faster, more reliable systems becomes critical. Traditional radio waves, while effective, have their limitations, especially when it comes to transmitting large amounts of data over interstellar distances. This is where laser-based communication systems come into play, offering a revolutionary leap forward. Laser communication, or optical communication, uses focused beams of light to transmit data at incredibly high speeds. Unlike radio waves, which spread out and weaken over long distances, laser beams remain tightly focused, allowing for faster and more efficient data transfer. NASA Laser Communications Relay Demonstration, for instance, has already shown promising results, achieving data rates up to 100 times faster than traditional radio systems. This technology could enable real-time high-definition video streaming from Mars or even farther, transforming how we experience and share discoveries from deep space. But the advancements don't stop there. Interstellar messaging is another frontier being explored. Imagine sending a message to a distant star system, not just within our solar system but light years away. Scientists are developing methods to encode and transmit information across these vast distances, using advanced algorithms and error correction techniques to ensure the message remains intact. While this might sound like science fiction, projects like Breakthrough Starshot are already laying the groundwork for such ambitious endeavors, aiming to send tiny probes to nearby star systems and establish the first interstellar communication links. Another exciting development is the use of quantum communication in space. By leveraging the principles of quantum entanglement, researchers are exploring ways to create ultra-secure communication channels that could revolutionize how we transmit sensitive data across the cosmos. While still in its early stages, this technology holds immense potential for future space missions, ensuring that critical information remains protected from interference or interception. As we look ahead, the future of space communication is not just about speed and efficiency. It's about creating a seamless connection between Earth and the farthest reaches of the universe. These advancements will not only enhance our ability to explore, but also bring us closer to answering some of the most profound questions about our place in the cosmos. With that in mind, let's turn our attention to another critical aspect of space exploration: the impact of space on human biology and how we're preparing for the challenges of prolonged space travel. Now, as we venture into the realm of human biology in space, it's essential to understand how the unique environment beyond Earth's atmosphere impacts our bodies. Prolonged space travel presents a host of challenges, from the absence of gravity to exposure to cosmic radiation, each of which can have profound effects on human health. These challenges are not just scientific curiosities, they are critical hurdles we must overcome to make long-term space exploration and colonization a reality. One of the most well-documented effects of space travel is the loss of bone density and muscle mass. In the microgravity environment of space, the body no longer needs to work against Earth's gravity to move or support itself. Over time, this leads to a weakening of bones and muscles, a condition known as spaceflight osteopenia. To combat this, astronauts engage in rigorous exercise routines, using specialized equipment like resistance machines and treadmills. Researchers are also exploring pharmaceutical solutions, such as drugs that stimulate bone growth, to help mitigate these effects during extended missions. Another significant concern is the impact of cosmic radiation. Unlike on Earth, where our atmosphere and magnetic field shield us from harmful radiation, space travelers are exposed to high levels of cosmic rays and solar particles. This exposure increases the risk of cancer, damages DNA, and can even affect cognitive function. Scientists are working on advanced shielding technologies, such as materials that can block or absorb radiation, as well as developing biological countermeasures like antioxidants and gene therapies to protect cells from damage. The cardiovascular system also undergoes changes in space. Without gravity, blood and fluids shift toward the upper body and head, leading to increased pressure in the brain and eyes. This can cause vision problems, a condition known as spaceflight-associated neuroocular syndrome. Researchers are studying how to manage fluid distribution in the body, using techniques like lower body negative pressure devices to simulate the effects of gravity and prevent these issues. Psychological health is another critical area of study. The isolation, confinement, and stress of long-duration space missions can take a toll on mental well-being. NASA and other space agencies are investing in research to understand how to support astronauts' mental health, from designing habitats that mimic natural environments to developing virtual reality systems that provide a sense of connection to Earth. Team dynamics and communication strategies are also being refined to ensure crews can work effectively and harmoniously in the challenging conditions of space. As we prepare for missions to Mars and beyond, understanding and addressing these biological challenges is more important than ever. The research being conducted today not only paves the way for safer and more sustainable space travel, but also has the potential to improve healthcare on Earth. For instance, studies on bone loss in space could lead to better treatments for osteoporosis, while advancements in radiation protection might enhance cancer therapies. With these insights, we're not just preparing humans to survive in space, we're equipping them to thrive. As we continue to push the boundaries of exploration, the lessons we learn about the human body in space will be invaluable, shaping the future of both space travel and life on Earth. And speaking of shaping the future, let's now turn our attention to the ultimate fate of the universe and what it means for humanity's place in the cosmos. As we shift our gaze from the challenges of human biology in space to the grand cosmic scale, let's explore one of the most profound questions in science, the ultimate fate of the universe. What lies at the end of time, and what does it mean for humanity's place in the cosmos? Theories about the universe's destiny are as fascinating as they are varied, offering a glimpse into the possible endings of everything we know. One of the leading theories is the Big Freeze, also known as the heat death of the universe. This scenario suggests that the universe will continue to expand indefinitely, driven by dark energy. Over trillions of years, galaxies will drift farther apart, stars will burn out, and the universe will grow colder and darker. Eventually, all energy will be evenly distributed, leaving the cosmos in a state of maximum entropy, a cold, lifeless void. While this might sound bleak, it's a reminder of the universe's vast timescales and the fleeting nature of stars, planets, and even civilizations. On the other end of the spectrum is the Big Crunch, a theory that proposes the universe could one day stop expanding and begin to collapse back in on itself. If the force of gravity overcomes dark energy, galaxies, stars, and planets will be pulled together in a cosmic reversal of the Big Bang. The universe would shrink to an infinitely dense point, potentially triggering another Big Bang and starting the cycle anew. This cyclical model offers a sense of cosmic renewal, suggesting that the universe might be part of an endless loop of creation and destruction. Another intriguing possibility is the Big Rip, where dark energy becomes so dominant that it tears the fabric of spacetime apart. In this scenario, galaxies, stars, and even atoms would be ripped apart as the universe expands at an ever-accelerating rate. This dramatic end would occur in a finite time, leaving behind a universe devoid of structure or cohesion. While this theory is less widely accepted, it highlights the mysterious and powerful nature of dark energy, which continues to shape the universe's evolution. These theories aren't just abstract ideas, they have profound implications for humanity. If the universe is destined for a big freeze, it underscores the importance of making the most of our time in the cosmos, exploring and understanding as much as we can before the lights go out. If the Big Crunch is our fate, it raises questions about the cyclical nature of existence and whether life could emerge again in a new universe. And if the Big Rip is possible, it challenges us to consider the fragility of everything we know and the limits of our understanding. Ultimately, the fate of the universe is a reminder of our small but significant place in the grand tapestry of existence. While these scenarios may seem distant and abstract, they inspire us to push the boundaries of science, explore the unknown, and cherish the time we have in this vast and mysterious cosmos. As we conclude our journey through the next era of space phenomena, let's reflect on how these discoveries not only expand our knowledge but also deepen our connection to the universe and our place within it. As we bring this journey to a close, let's take a moment to reflect on the incredible phenomena we've explored together. From the breakthroughs in interstellar travel and the search for exoplanets to the mysteries of black holes, dark matter, and the ultimate fate of the universe, each discovery has opened new doors to understanding the cosmos. These advancements are not just scientific milestones, they are invitations to dream bigger, to ask deeper questions, and to marvel at the vastness of the universe we call home. The next era of space discovery promises to be nothing short of revolutionary. With cutting-edge technologies like the James Webb Space Telescope, advancements in artificial intelligence, and the rise of private space companies, humanity is poised to uncover secrets that were once beyond our imagination. Whether it's the potential for space mining, the development of self-sustaining habitats, or the search for extraterrestrial life, the possibilities are as limitless as the universe itself. But beyond the science and technology, what truly stands out is the sense of wonder and connection these discoveries inspire. They remind us that we are part of something much larger, a cosmic story that began billions of years ago and continues to unfold with every new observation, every new mission, and every new question we ask. The universe is not just a place to explore, it's a source of endless curiosity and inspiration. So, as we conclude this exploration of the next era of space phenomena, I encourage you to stay curious. Look up at the night sky and wonder about the mysteries that lie beyond. Follow the latest discoveries, engage with the science, and let your imagination soar. The universe is vast, and our journey to understand it has only just begun. If you've enjoyed this journey through the cosmos, don't forget to like this video, subscribe to the channel, and hit the notification bell so you never miss an update. Together, let's continue to explore the wonders of the universe and celebrate the incredible potential of the next era of space discovery. Thank you for watching, and remember, the stars are waiting.